A warm welcome. This is Electric Energy Generation Utilization and Conservation course with lecture 3.2 focusing on resistance heating and induction heating. Resistance heating. Actually, this method is purely based upon the I square R effect, the loss effect, and it has wide applications such as heat treatment of metals like annealing, normalizing, hardening, tempering, drying, and baking of potteries, domestic cooking, etc. In microwave oven as well as in certain ovens, the wire resistances are employed for heating. Temperature is above 1000 degrees Celsius can be obtained. Whenever current is passed through a resistive material, heat is produced because of the I square or losses. There are two methods of resistance heating, namely direct resistance heating and indirect resistance heating. We can diagrammatically see how direct resistance heating is made. We are having two electrodes. One is the positive and the other one is negative. Either it is supplied with the DC or AC supply. These electrodes are being immersed into a high resistive powder. Below that we are having the charges present. Now, when electricity is applied, the electrodes will automatically create a heat, and this heat is used to melt the charge present inside the furnace. This is direct resistance heating. If suppose it is an indirect resistance heating, we can see that the electricity is passed through the filament which is present inside, or else the heating element is present inside the heat chamber, and only the heat chamber will be having contact with the charge. When heat is increased here, the temperature of the heating chamber also increases, and that temperature impact will create a melting of this charge. Next is induction heating. While considering the induction heating, it is mainly depending upon the principle of electromagnetic induction. This is how this is what the principle they are using in the transformers. There is a primary winding where AC current is being supplied. The coil is magnetically coupled with the metal to be heated, which acts as a secondary. An electric current is induced in this metal when the AC current is passed through the primary coil. The following are the different types like the core type furnaces and coreless type furnaces. Let us consider the core type furnaces where we have direct core, vertical core and indirect core type furnaces. Let us see the direct core type furnaces. Here we can see that the primary winding is here at one arm of the iron core. So it is like a transformer, isn't it? So here we are providing the supply. So when supply is applied, a current flows through, flux is created, and when this flux is passing through this iron core, automatically there will be the production of an opponent flux here. It will induce a flux here. Due to that flux, current will be flowing through the circuit, and this current will start increasing it will start to increase the temperature of the charge, and it will melt the charge required. This is direct core type. While you are considering indirect core type induction, we can see that the primary winding is present at this condition, and the secondary winding is having a small layer below the primary winding setup. This is how they will be arranged. The secondary winding is here, and the core is present, which is not touching the interior portion. This part is not being touched by the core or the secondary winding. In such a case, we can have a indirect core type of induction. When electricity is passed through, the transformer effect, the flux passage, the flux linkage will create the condition, the current to flow through in the secondary winding, and there we'll have the current flow, and this current flow will be ready to melt the charge present. And while you are considering the coreless induction furnace, there is no core here. We are simply using a ceramic crucible, which is like a container where the charge is placed. And here we are having the primary winding at one side, and the secondary. Here the primary winding is wound around the core, sorry, not core, around the ceramic crucible. This ceramic crucible will be acting like a secondary. So there will be an induction principle between this primary winding and the ceramic crucible, and this will create, the current will be flowing through the ceramic crucible where the electricity is passed through the material, and the temperature gets increased in the charge, thereby melting the charge.